right, as we look at our first illustration in section 1.8, our goal today is to understand properties. Just why can we do what we do? All right? It's like, what is the rule that lets us do these things? And so I've got a number of little illustrations, and then we're going to write down some examples of these. We'll try to move through them fairly quickly, but it's pretty straightforward. Does anyone have a parent that goes to Chicago every day on the train? What are they called, John? Those guys who get on the train and go to Chicago and get off the train. What are they called? Commuters. You heard the phrase? They're called commuters, right? Now, let's say that here are our commuters. We have Jacob and Catherine and James and Brittany. They get on the train all together every morning. Good morning. They have their coffee cups, suits and ties, whatever their dress is. Maybe Catherine's a computer programmer. She's in a casual work environment. She's in there in jeans and a flannel shirt, going to make her awesome computers for Microsoft. They get on the train every day because they've got to know each other, and they actually sit on the same car. Do they get off the train in the same order as they got on? No. But they still got off. And they still got on. The same four got on as got off. True? And we call these people who ride on trains what? Commuters. All right. Say that top word. Commutative. Notice there's two T's in the middle. Two M's, two T's. Commutative. It's off the same root word as commuter. It means to move around. You mean math and English are related? Yes. Okay? Notice what happens in the equation to the right. Are they getting off the train in the same order? No. What are they doing? They're changing around. So when the order changes around, we call that commutative. That's all. That's all you have to remember. They're getting off the train in a different order. Someone give me a mathematical number illustration of this. Really hard here. Maggie, go. 1 + 2. Equals? Star for the day. Give it up for Maggie. Well done. Hey, there's no sense in making your illustrations complicated. Okay, she did a nice simple illustration. Now, does this property work for multiplication as well? All right? Is this true? What's 5 times 2?
10.
Okay, now big question here. What's 2 times 5?
10.
10. So what do you know it works for multiplication as well?
Woohoo.
Does it work for subtraction? No. So notice there's two properties here, addition and multiplication. Does it work for division? No. It just works for the big addition, multiplication properties. All right. Now, second illustration. We need to think. Here we have Larry, Mo, and Curly. All right, the Three Stooges. And Larry is talking to Mo. Yuck, 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 yuck. And they're talking together. And of course then Larry says something dorky. And Mo gets mad at him, turns around, and now talks to Curly. Are they still all together, though, in the same line? Yeah. Did anyone change positions? No. Mo just turned around and talked to Curly. That's the idea of associating with someone. Grant, if you turn to Tori, you're associating with her and not with Adriana. But as you turn your head, now you're associating with Adriana and no longer talking to Tori. You can't talk to two people at the same time with eye contact. All right? So, with addition, we have a very simple illustration. 2 + 4 + 6. Let's think through that. That's 6 + 6, which is what?
12.
12. All right, on the other side, let's see if it also works. 2 plus the quantity, 4 + 6. So 4 + 6 is 10, plus 2 is 12, so 12 equals 12. What do you know it works? All right, so we have the associative property for two things, addition and multiplication. Association, I want you to think parentheses are moving, but nothing else. All you're doing is turning your head and talking to a different person. You're not moving. You're associating. I talked to Bailey I talk to Jacob. I'm not looking at Bailey. I'm looking at Jacob. I turn my back on Jacob, and I talk to Bailey. The middle person moves, and the parentheses move. All right? So put a little note out to the left that says, parentheses move. And we need to review an idea here. What is that word I just wrote?
Parent.
Can everyone spell parent? Okay? Parent is the beginning way to spell parentheses. And then you say he, and then SES. What letter is not in parentheses? I is not in there. Okay? It's all about our parent, he sees. He says something. Anyway, moving on. We don't need an illustration for multiplication there because it's very straightforward, but if you needed one, we could say 2 times 3 times 4 equals 2 times 3 times 4. In both cases, we get 24 as an answer. All right, our next two. I'm going to put a box around them. There's nothing you can do to make God love you more. And there's nothing you can do to make God love you less. Right? Your identity in Christ stays the same. Always. When the problem doesn't change from start to finish, the identity stays the same. Did we start with an A?
Yeah.
Did we end with an A?
Yeah.
You get it?
Yeah.
Hey? It's a good Canadian problem.
Canadian.
All right, so we started with an A. 10 plus 0 equals 10. The other one, does the identity property work for multiplication? 7 times 1 equals 7. Chance to be a cool math student. Use cool math font. That's the identity property. Okay? The number doesn't what? Change. Remember the abbreviation for change? Little delta? Little Greek symbol there? It's Greek. Fourth letter in the Greek alphabet. It's a capital D. Delta. All right. Put a little cloud around the next two.
Wow.
It's fun to draw. That and sound effects. Inverse means you knock itself out. Okay? That doesn't mean I want you to turn to your partner and knock them out. Okay?
No.
It means to cancel each other out, so to speak.
I'll not do that if you want to be knocked out.
All right. So, as we work through this, A plus the opposite of A, notice I didn't say negative A, I said the opposite, cancel each other out. So, is this true? 5 plus negative 5 equals 0. Yeah, that's an example of inverse. They knock each other out. Remember this word? How do we say it? Give me someone. Multiplicative. Multiplicative. Multiplicative inverse or reciprocal. Now, you're going to have a homework problem tonight that's going to write this as a decimal. Can anyone tell me what 0.5 is as a fraction? 1/2. So when you get a decimal thrown at you, don't get freaked out about it. It could be written as a fraction. But as a general rule, 1/4 times 4, remember that's 4 over 1, that becomes 4 over 4, which reduces to 1. Reciprocals, when multiplied together, always, always, always cancel. If you need help with that, see Dara or Matt. They'll help you out. All right, moving on. Distributive. Remember when we passed out candy?
Can we get some more?
M&M, 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 M&M. But that table's special over there, so they don't get any. M&M, 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 and M&M. That's not fair. You got to pass out one M&M to what? Everybody. If you're going to distribute it evenly. So the A gets multiplied to the B, and the A gets multiplied to the C. Draw your little arrows. Think of the monkey throwing bananas. You know, he throws bananas out to everyone on his team. All right, and we get AB plus AC. Here we go. Here's my example. 5, open parentheses, 2x plus 9, close parentheses. Who's comfortable to give me what they think would be the answer? Talk to me here. John, take it away.
10x plus.
Yes. I love how you got the 45 in there because you got to multiply it both to the 2 and to the 9. That's distributing. That's what we did, what, Friday, was it? Okay, so that's the property. All right, and then finally, let's box in our final two, because that's a pair. Leave space at the end of your box, notice, because we're going to put things out there. When you multiply anything by -1, you get the opposite of what you started with. Notice I didn't say negative A. I said the opposite of what you have. Is it possible that A can be negative? What's the opposite of a negative? A positive. And that's where we stood on the chairs. Remember, a negative times a negative is a positive. So, let's do an example of this. Pick a number. 5. Stay away from 0. It doesn't always, it throws things off. -1 times 5 is -5. The last but not least, sometimes this property is forgotten about because it's so straightforward. Nate, when's your birthday? September. That's a 9. So, 9 times 0 equals 0. Anything times 0 equals 0. Simple property. All right, so look, I want you to look down those, each one right now. Look down them with your eyes. How do you spell commutative? 2 M's, 2 T's. Okay? All right.